For question 1, we are looking at a frequency distribution. And with a frequency distribution, we always have classes, which are just ranges of numbers, ranges of values here. And we want to count how many pieces of data fall within each range of numbers within each class. So just looking at our classes here, the first one is all the numbers from 10 to 18, and there's 4 pieces of data somewhere in between the ranges of 10 to 18. There are 7 pieces of data somewhere in the range between 19 and 27. So that's how you read this frequency distribution. And now let's answer the questions here that are being asked. The total number of observations or pieces of data here, we would just want to add up all these different frequencies. So if we do that, we should get 26, which is our solution. So counting how many pieces of data fall within each different class, each different range of values, gives us the total amount of data that there is. The width of each class, if you counted from 10 to 18, 10, 11, 12, 13, 14, 15, 16, 17, 18. That's 9 numbers. The same thing if you counted 19 to 27. There's 9 numbers there. So that is one way to think about the width of the class, how many actual numbers there are within each class, within each range of values. Another way to get that is you can subtract the lower limits from one another. So for each class, I would say 10 is the lower limit and 18 is the upper limit of the first class. 19 is the lower limit and 27 is the upper limit of the second class, and so on. So if you did like the lower limit of the second class, 19 minus 10, you get 9, which is the width of the class. Or if you did 28 minus 19, you again get 9. So just looking at consecutive classes and subtracting the lower limits, you get the width. You also get that if you do the upper limits. 27 minus 18 gives you 9, 36 minus 27 gives you 9, and so on. So that's how you can find the width of the class, either by counting or by subtraction. The midpoint is the value that's going to be right in the middle of each range of numbers of each class. The easiest way to do that is to find the average. So add the lower limit plus the upper limit and divide by 2. So if I did that for the second class here, 19 plus 27, that gives me 46. Divide that by 2, I get 23. That's the average, which is going to be the number in the middle when you average the lower and the upper limit, the midpoint. And so the modal class is going to be the class, the range of numbers that has the most data in it. And looking at our values here for the frequency for how much data is in each class, there's 2 of them that have 7 data values. So there are 2 modal classes, and you would need to write them both down with a comma separating them. For this example, 19 to 27 has 7, and 37 to 45 also has 7. And the last question is saying, what if we added one more range of numbers, one more class, what would it be? Notice all the classes are the same size. They all have class width of 9. So the next one will follow that same pattern. We pick up right where we left off. From 63, we go to 64, and then we include 9 total numbers, which would be up to 72. And you can check that you have the correct answers. 72 minus 63 is 9. And also 64 minus 55 is 9. So that class width holds true with the next additional class. For number 2, we have a table here with 20 values in it. And for this example, it says it is the population of cities, the 20 most populous cities in the world. 13.4 is 13.4 million people, and so on. We want to create a frequency distribution for this data, and it has it started for us here. So our first class is 7.0 to 7.9. So our next class should be have that same width and pick up right where we ended. So from 7.9, our next one would be 8.0 and go to 8.9, and then 9.0 to 9.9, and so on. Those will be all of our different classes. And now to fill in this side of the frequency distribution, we're just going to count. So what we would do is we would go through these 20 data values and find out how many of them fall within the range 7.0 to 7.9. And so we would do that by counting. One thing that's nice about this is it looks like they're in descending order. So if you go down the columns, they get smaller. And so you can kind of just start with the smallest data here and see how many you have that are in between 7.0 and 7.9, and there's 8 of them, so 8's my first answer. And then just continue where you left off and see how many fall in between 8.0 and 8.9, and I'm counting, there's just 1, and so 1 would be my frequency for that next class, that next group. And then continue doing that. Make sure you don't leave any of them out. These numbers should add up to 20 since there's 20 total cities and they all have to fall into one of these groups, one of these classes. But just fill in your frequency table, and that's what we're looking for here. For question 3, we're making a stem and leaf display, and you have to get used to these to read them. So this first number here to the left of this vertical line is the first chunk of the number, and then all these digits to the right side of this vertical line, they each represent an individual piece of data here in the table. So for example, let's look at this line here with the 1. The first part of the number is 1, and then this 1 here would make 11. A 1 and a 1 make 11, and you can see there is a data value of 11. The next number here is a 2. So the first part of the number is a 1, and with a 2 on it, that makes it 12. And there's a piece of data that's 12, and so on. So this row is just saying that in our data, we have an 11, a 12, a 15, 2 16s, 2 17s, and an 8. And that's how you would read the stem and leaf display. The 20s, we have a 21, 2 23s, a 27, and a 28, and so on. And so one of the biggest things to look out for as you're creating this is to make sure you account for every single number. Don't double count something, don't leave something off. So it can be helpful if you can somehow get this copied down to a pen and paper, or you can copy it into Excel and like highlight or cross numbers off as you use them, as you type them in here, because you can see you want them in order. We had 21, and then our 23s, and then our 27, and then our 28, and so on. So it can kind of be hard to look at this big table just on your computer monitor and not being able to cross things off you've already used, not being able to manipulate the data. It can be easy to overlook a number or double count something. So figure out a way to either copy this down to pen and paper, print it out, or put it in Excel. I think will help organize as you create your stem and leaf display. For question 4, we have a histogram here. And watch this video, it gives a good introduction to histograms and also frequency distributions. For question A, how many students worked between 10 and 14 hours per week? So the numbers here on the bottom horizontal axis are our range of data values. And the height of each bar represents how many people fall within each of our different data value ranges. So you can see between the range of 5 to 9, hours of weekly work, there's 3 students who fall within that group. So this question between 10 and 14, we just need to see how high the bar is, and it looks like it's at 8. So there's 8 students who work between 10 and 14 hours per week. How many students worked more than 34 hours? Well, that's actually just going to be just this one bar here for the 35 plus, and we can see that it has a height 3, it looks like. So that's our answer. If this question said something like how many students worked more than 29 hours, we would have to add these two values together, the people who worked 30 to 34 and also those who worked 35 plus. But since there was just one group, one bar to the right of 30 to 34, we can just take that value of 3 and that's our solution. How many students worked 10 to 19 hours per week? This is kind of what I was just talking about. This is asking us to combine multiple groups here. So we want to combine the 10 to 14 plus the 15 to 19. There's 8 students in that group. And it looks like there are 4 students in this group. So 8 and 4 makes 12. There's 12 students in that range, 10 to 19. How many students worked at least 10 hours per week? And so all of these groups are at least 10 hours. The only group being left off is the 5 to 9 students. And so we need to add all these numbers up. An 8 plus a 4. In the 20 to 24 range, we had 12 plus another 8, a 4, and a 3. If you add all those up, you should get 39. So out of the 100 students surveyed, how many indicated that they were employed at the time of the survey? So notice there's all, these numbers don't add up to 100. So we just added up all of these bars and got 39, and then plus the 3 students we didn't count in part D here, this previous problem. That means all of these bar heights together combine for a total of 42. And so notice it did say that up here. Only those who reported employment are being shown here. And since our bar heights total 42, 42 out of the 100 students are indicated that they were employed when they took the survey. How many students reported working 6 hours per week? So that's one thing we can't tell in a histogram. We know there were 3 students that worked somewhere between 5 and 9 hours. We don't know if any of those worked 6 hours or if all 3 of them worked 6 hours. It can be any number that they reported between 5 and 9 and they would have been in this bucket. So with a histogram, you can't tell exact, precise data values like this. So our answer here would be the information is not available. How many students reported working 2 hours per week? Well, in our bucket of 0 to 4, since no students are in that, there couldn't have been any who reported 2 hours per week. So we can actually say that no students reported that, even though that is a specific data value of 2. We couldn't answer how many reported 6. We can answer how many reported 2 because we know there are 0 students in that entire bucket. So which of the following sets of data might have been used to construct the histogram? So what you kind of got to do here, I mean, we can just start with the 5 to 9 range. You should see 3 values between 5 and 9. So if I just look at A here, I see 5, 6, 7, 8, 9. I see 5 values there. I know this A cannot be the answer. Now I know B can be an answer, but it looks like C could as well, so I can't rule out either one of those. I would have to keep going through until I see values down here that clash with the histogram. So from 10 to 14, I should see 8 values. And you can count that here. I think that might throw C out. I got 3, 7, 8, 9, 10, 11. Yeah, so there's way more in the 10 to 14 range. So now C is also not an answer, but B is still a contender because there are 8 numbers between 10 and 14. So you would want to make sure that all these, for your answer choice that you choose, you want to make sure that each bucket of numbers, however many numbers there are, line up with the height of the bar, and then that will be the correct data values that could correspond to this histogram. For number 5, another video to watch to introduce you to this type of problem. So go through that. What it's asking here is we have a circle graph that represents a sample of 600 people. So 600 people are split between the slices of the pie here in our circle graph. And we want to know how many people indicated that they would prefer Bluetooth capability for the automobile accessory that they want on a family road trip. And it gives us the percentages that go along with each slice of the pie here. And it says, in this example, Bluetooth capability is 29%. So you need to find out what 29% of 600 is. And you can do that in a calculator by typing in 600 times 0.29. I'm going to do it here in Excel just to illustrate. 600 times 29%. Make that percentage a decimal. 0.29 is the equivalent of 29%. And so 29% of 600 people is 174 people. So that's the answer we're looking for here in number 5.